Hey everyone, and welcome back to the channel. Today, we're re-diving into a topic that's on every aspiring tech professional's mind. What programming language should I learn for artificial intelligence? You hear about R. You hear about Julia, maybe even C++. But time and time again, one language stands tall above the rest. You guessed it, we're talking about Python. So, is Python really the one language you still need for AI? Let's break it down. First, let's address the elephant in the room. Why Python? Why has this one language become so dominant in the world of AI and machine learning? The answer is beautifully simple: accessibility and community. Python was designed from the ground up to be readable and easy to learn. Its syntax is clean and intuitive, almost like writing in plain English. This low barrier to entry means that researchers, data scientists, and mathematicians, people who are unnecessarily hardcore software engineers, can pick it up quickly and start building powerful models without getting bogged down in complex code. Think about it. The goal of AI development isn't just to write code, it's to solve complex problems, to experiment with new ideas, and to iterate fast. Python's simplicity allows for rapid prototyping. You can have an idea for a neural network in the morning and have a working prototype by the afternoon. This speed is absolutely critical in a field that moves as quickly as artificial intelligence. You don't want to spend weeks just setting up your environment or wrestling with complicated syntax. You want to get straight to the data, the algorithms, and the results. Python lets you do exactly that. But a language is only as strong as its ecosystem, and this is where Python truly shines. The community around Python is massive, active, and incredibly supportive. This isn't just about finding answers on Stack Overflow, though that's a huge plus. It's about the sheer number of powerful open-source libraries and frameworks built specifically for AI and data science. Let's talk about the heavy hitters. You can't have a conversation about AI in Python without mentioning NumPy and Pandas. NumPy is the fundamental package for numerical computation. It provides support for large, multidimensional arrays and matrices, along with a huge collection of high-level mathematical functions to operate on these arrays. Essentially, it's the bedrock that makes handling massive datasets efficient. Then you have Pandas, which is built on top of NumPy. Pandas introduces the data frame, a super flexible and intuitive data structure that makes cleaning, transforming, analyzing, and visualizing data an absolute breeze. If you're a data scientist, you're probably spending most of your day living inside a Pandas data frame. Once your data is prepped and ready, you need to build your models. And again, Python's ecosystem has you covered with some of the most powerful machine learning libraries in the world. Scikit-learn is the go-to for traditional machine learning. It offers a simple and consistent interface for a vast array of algorithms, from regression and classification to clustering and dimensionality reduction. Its documentation is fantastic, making it incredibly easy to get started with implementing and evaluating different models. But what about the deep learning revolution? This is where Python's dominance becomes undeniable. Two frameworks lead the charge: TensorFlow and PyTorch. TensorFlow, developed by Google, is a comprehensive end-to-end platform for machine learning. It's known for its scalability and production readiness, powering everything from Google Search and Photos to large-scale enterprise AI solutions. It has a high-level API called Keras that makes building and training complex neural networks feel almost like stacking Lego bricks. It's incredibly powerful, yet surprisingly user-friendly. On the other side, you have PyTorch, developed by Meta's AI Research Lab. PyTorch has gained immense popularity, especially in the research community, for its flexibility and Pythonic feel. It uses a dynamic computation graph, which makes debugging and experimenting with novel network architectures much more intuitive. The TensorFlow versus PyTorch debate is a whole video in itself, but the key takeaway is that both of these state-of-the-art deep learning frameworks are Python first. This means that to be on the cutting edge of AI, you need to be comfortable with Python. So Python is easy to learn and has amazing libraries. What else? Platform independence. Python code runs on Windows, macOS, and Linux without any major modifications. This is crucial for collaboration. A team of developers and researchers using different operating systems can work on the same project seamlessly. Furthermore, major cloud platforms like Amazon Web Services, Google Cloud, and Microsoft Azure all have excellent first-class support for Python. You can easily deploy your Python-based AI models to the cloud, scaling them to handle massive amounts of traffic and data. This seamless transition from local development to global production is a massive advantage. Now, I know what some of you might be thinking, but isn't Python slow? This is a common criticism. As an interpreted language, Python is indeed slower than compiled languages like C++ or Java for performance-critical tasks. This can be a bottleneck. However, this is where the magic of the Python ecosystem comes in again. Many of the core AI libraries we just talked about, like NumPy and TensorFlow, aren't actually pure Python. Their performance-critical parts are written in C++ or CUDA and then wrapped in a user-friendly Python interface. This gives you the best of both worlds, the rapid development and ease of use of Python, combined with the raw computational speed of C++. You get to write your logic in simple, readable Python, while the heavy number crunching happens at near-native speed under the hood. So, for the vast majority of AI applications, Python's performance is more than sufficient. You're not sacrificing speed. You're just outsourcing it to highly optimized pre-compiled libraries. Let's consider the job market. If you're learning a skill to build a career, you want to know it's in demand. A quick search on any major job board for AI engineer or data scientist will show you one thing very clearly. Python is a non-negotiable skill. Companies are looking for people who can hit the ground running, and that means being proficient in the tools of the trade. Right now, and for the foreseeable future, those tools are overwhelmingly Python-based. By learning Python, you're not just learning a language, you're gaining access to the largest and most dynamic job market in the tech industry. So, to wrap it all up, are there other languages used in AI? Absolutely. R is still very popular in academia and statistical analysis. Julia is an exciting up-and-comer, promising C-like speed with Python-like syntax. C++ is often used for deploying models in high-performance environments like self-driving cars or gaming. But none of them offer the same complete package as Python, a gentle learning curve, an unparalleled ecosystem of libraries, massive community support, platform flexibility, and overwhelming industry demand. If you are just starting your journey into AI, or if you're a professional looking to pivot into this exciting field, Python is not just a good choice. It's the most strategic choice. It is the lingua franca of modern artificial intelligence. It's the one language that connects all the dots from initial idea to final deployment. It's the one language you still absolutely need to know. Thanks so much for watching. If you found this video helpful, give it a thumbs up, and don't forget to subscribe for more content on AI and programming. Let me know in the comments what your favorite Python library for AI is, or what topics you'd like to see covered next. See you in the next one.